In this video, we're going to take a quick look at the new Neural Kriging tool introduced in Geoscience ANALYST Pro Geology version 4.6. To use with the tool, I've prepared some copper point data using drill hole sample intervals in the Flin Flon demo dataset. These copper values were capped and then composited on 6-meter long intervals. And I've also included some geological unit classification and Ishikawa alteration index values on these points. We'll take the copper values and use the Neural Kriging tool to interpolate them onto a 12-meter square block model. The block model we're using here already has geological information on it, which I generated using the interpretation section tool that comes with Pro Geology and the surface designer that comes with Regular Pro to create some surfaces and then write values to the block model using those surfaces. I also already interpolated the Ishikawa index onto the block model using the RBF interpolant tool that comes with Pro Geology. We'll need these extra properties because of one of the key differences between neural kriging and traditional kriging. Neural kriging is different than the traditional method in that it uses a convolutional neural network to learn spatial continuity directly from the data. Spatial relationships are captured implicitly without defining a variogram. So no variogram is required, but results can be limited in very sparse data sets. In such a case, like this, secondary variables are especially important. We'll use the geological information and the alteration index. They'll help the model to detect spatial structure in more than just X, Y, and Z directions. You can find the Neural Kriging tool with the other Pro Geology tools under the Geology menu in version 4.6. Let's open it up and start picking our inputs. Source input is going to be our points. The client will be the block model. The data is going to be the copper value to interpolate. For distance threshold, let's choose 100. We'll choose the geology information and alteration index for secondary data. They'll need to be available both in the source data on the points and in the client data on the block model in order to be used with the Neural Kriging tool. And then optionally, we can pick our own output name and save the training model to reuse in this part of the input section. This saves some time and will prevent you from changing any of the other parameters that went into training that initial model. Hitting OK will run the process in an external window. And since we didn't decide to reuse an existing model, the model is first going to be trained. This typically takes a little bit longer than actually running the prediction. As the model is trained, the prediction process takes place, and when that's complete, the property is written back into the workspace and attached to the client object. Let's take a look. So now we're visualizing the interpolated copper values on the block model against the input copper values on the points. And walk through a few sections here to take a look. And we can also have a look at the data blending option to see what role the secondary variables played in the Neural Kriging. So take a look at the lithology and at the alteration index. And that is the Neural Kriging tool. For more information on Geoscience Analyst Pro or Pro Geology, please head over to our website at mirrorgeoscience.com or check out our YouTube channel. And for more information on the Neural Kriging tool, you can find the documentation pages by clicking on the little blue help button. That'll redirect you to the Read the Docs page. Thanks for watching.